Hello students, welcome to Parmar Academy. Today we will discuss about the chapter polynomials of grade 9. So let's start. So first of all, what is a polynomial? A polynomial is an expression that consists of variables, constants that involves the operation of addition, subtraction, multiplication, and the one very important thing is that the exponents are non-negative integers. Now, what is the meaning of that non-negative integers? That means the powers are either 0 or the positive integers only. So, let's clear this with the example x square plus 5x minus 7. Here, this is a polynomial in which variables are x and the constants are plus 5 and minus 7. And the powers is 2 here, power 1 here. Here this is constant, so we will let it at power 0. In the second one, x cube y4 plus 5x square y plus 4. Here the variables are x and y and the constants are 1, 5 and 4. And the exponents are 3, 4, 2, 1 and 0. Let's understand this with more examples that which of the following are the polynomials. The first example is x square plus 5x minus 5. Clearly it is a polynomial because all the powers exponents are non-negative integers. So yes, it is a polynomial. The next one is x raised to power 3 by 2 plus 4x cube plus 3. It is not a polynomial because here in the first term the power of x is 3 by 2, that is 1.5, and it is not a integer. So it is not a polynomial. In the example number 3, x raised to power 5 plus x raised to power minus 2 plus 6x. In the second term, the exponent of x is minus 2. That is, again, it is not non-negative integer. So it is also not a polynomial. For the next example, it is 3x square plus 5 by x minus 7x. On the first side, it looks like that it is a polynomial because all the powers are positive, but this converts into 3x square plus 5. 5 upon x is written as 5x raised to power minus 1 minus 7x. Now here, in the second term, the power of x is again negative. So it is not a polynomial. For the last example, 5x square y cube plus 3xy plus 4y square. Here all the exponents are non-negative integers, so yes, it is again a polynomial. Now, so we will classify the polynomials on the basis of number of terms. Means इस slide में हम क्या करेंगे, हम polynomials को उनकी number of terms के basis पे classify करेंगे. वो polynomials जिनमें एक term है, वो polynomial जिनमें दो terms है, या वो polynomial जिनमें तीन terms है. So, for example, 5x raised to power 9. This is a polynomial having only one term. So polynomials with one term are called monomials. Polynomials with one term are called monomials. The next one is 5x plus 3. This is again a polynomial having two terms. The first term is 5x and the second is 3. So polynomials with the two terms are called binomials. Next one is 7x square minus 4x plus 5. This polynomial has three terms and the polynomials with the three terms is called trinomials. The next one, let's check, name the following polynomials on the basis of number of terms. यहाँ पर हमें क्या करना है, हमें इन polynomials को check करना है on the basis of number of terms. So let's start. The first polynomial is 3x square plus 8x minus 7. This polynomial has three terms, so it is a trinomial. It is a trinomial. The next one is 5x raised to power 58 plus 9x. This polynomial has two terms. The first term is 5x raised to power 58 and the second term is 9x. So this is a binomial. And the last one is 47x raised to power 5. Clearly, this polynomial has only one unique term, so it is a monomial. The next one, here again we have to check the polynomial on the basis of number of terms. The question is 5x plus 6x square plus 2x. In the first side it looks like it has three terms, that is first term is 5x, second term is 6x square, and the third term is 2x, and the answer is trinomial. But this is not the trinomial, because whenever we have to answer, first of all we will solve the polynomial if it is possible. So its answer is binomial. Why? Look at here on the solution. Solution is 5x plus 6x square plus 2x. Here 5x first term, 2x third term, both are like terms, and we know that the calculation is possible on the like terms. So 5x plus 2x is 7x plus 6x square, means the three term polynomial reduces into two term polynomial. So that's why it is not a trinomial, it's a binomial. So move to the next slide, that is degree of a polynomial. Here we will discuss about the degree. What is degree? Degree क्या है polynomial की? Actually degree is the highest exponent in a polynomial. For example, the degree of a polynomial is the highest exponent value of any of its term. For example, 5x square plus 6x minus 7 having degree 2. Because here power is 2, here power is 1, and here this is a constant term, so the maximum power is 2, so degree is also 2. In the next example, 3x square plus 7x raised to power 9 minus 8x raised to power 10. The first term having exponent 2, in the second term exponent is 9, and in the third term exponent is 10, and the maximum power is 10. So that's why this polynomial having the degree 10. Now next we will classify the polynomials on the basis of degree. As we had done the classification of polynomial on the basis of number of terms, now here we will classify the polynomials on the basis of their degree. The first one, look at here, 5x plus 3. 5x plus 3 is a polynomial where the maximum exponent, highest exponent is 1. So polynomials with the degree 1 are called linear. Polynomials having degree 1 are called linear. In the next example, 7x square plus 3x minus 4. Clearly in this polynomial the highest exponent is 2, that means degree is 2. That means that polynomial of degree 2 are called quadratic polynomials. Polynomials of degree 2 are called quadratic polynomials. In the next example, x cube plus 5x square minus 6x plus 8. In this polynomial, the highest power, highest exponent is 3. The highest exponent is 3, and the degree polynomial of degree 3 are called cubic polynomials. And in the last example, x raised to power 4 plus 8x cube minus 4x square plus x minus 4. Here the maximum highest power of this polynomial is 4, and the polynomials of degree 4 are called biquadratic. So again, once again I will repeat that polynomials of degree 1 are called linear polynomials, polynomials with degree 2 are called quadratic polynomials, polynomials with degree 3 are called cubic polynomials, and polynomials with degree 4 are called biquadratics. The next, here we will find out the degree of the following polynomials. So let's start. First polynomial, 3x raised to power 4 plus 7x raised to power 5 minus 2x raised to power 7. Here in this polynomial the highest power is 7, so clearly degree of this polynomial is 7. For the next example, 4x raised to power 8 minus 6x raised to power 9 minus 3x square. Here the maximum power, highest power is 9, so degree of this polynomial is also 9. The next one is 7x raised to power 19 plus 19x raised to power 7 minus 7x8. The highest exponent in this is, that is 19, so degree of this polynomial is 19. And the last one is 4x raised to power 100 minus x raised to power 79 minus 45x raised to power 45. The highest exponent of this polynomial is 100, so degree of this polynomial is 100. Now we learn that how to find the degree and to classify the polynomials on the basis of a degree. So next, give an example of a trinomial of degree 8. We know that what is a trinomial? A trinomial is a polynomial having 3 terms, and degree 8 means the highest exponent is 8. So the examples are, the first example is 4x raised to power 8 minus 6x raised to power 3 plus 7. Clearly this polynomial has 3 terms and the highest power is 8. So this is one of the example of a trinomial of degree 8. The second one example is 54x plus 4x raised to power 8 minus 3x raised to power 6. Again, this polynomial has 3 terms and the highest power is 8. So this is the example of trinomial of degree 8. Now let's come to the next topic, that is factors. So what is a factor? When we divide a number m by the another number n, if the division is exact, then we will say that m is the factor of number n. Now here, what is the meaning of exact division? The meaning of exact division is remainder 0. Let's discuss it with some examples. The example number 1 is when 8 is divided by 2. Clearly when 8 is divided by 2, we get the answer 4 and the remainder is 0. So here remainder is 0 means this division is exact. That we will say that 2 is the factor of 8. In the next example, here when we divide 9 by 2, at the last we will get the remainder 1. That means here the division is not exact. Clearly we know that 2 is not the factor of 9. Similarly, in case of polynomials, when a polynomial px divides another polynomial gx, exactly we will say that px is the factor of a polynomial gx. Now, as the whole discussion depends upon the remainder only, so first of all we will learn how to find the remainder. There are 2 methods, the method 1 direct division and the method 2 is substitution method. So let's take example, the check either x minus 2 is factor of x square minus 3x plus 2 or not. Here we have to check that this one is factor of this polynomial or not. So clearly we will try to find the remainder first. If the remainder is 0, we will say that this is a factor. If the remainder is not 0, that polynomial is not the factor of this one. So first method is by the division method. So here we will divide the polynomial x square minus 3x plus 2 by x minus 2. Clearly here this is x square and this one is x. We will multiply the x minus 2 by x. X into x, that is x square, minus x into minus 2 is minus 2x. Change the sign. Plus x square and minus x square get cancelled out. Minus 3x plus 2x equal to minus x. And 2 get carry plus 2. Now multiply the polynomial by minus 1. Minus 1 into x, that is minus x. Minus 1 into minus 2, that is plus 2. Again change the sign. That minus x is cancelled out with plus x and plus 2 is cancelled out with minus x. So at the end we will get the remainder 0. Here the remainder is 0 means this is x minus 2 is a factor of x square minus 3x plus 2. Now again we will check this by the another method. Here there are 2 steps. The step 1, we will put the x minus 2 equal to 0. X minus 2 equal to 0 and we will get the value of x, that is 2. Now in the next step, in the step 2, we will put this value in the polynomial and check the answer. X square minus 3x plus 2 at point x is equal to 2. Now replace x by 2. It is 2 square minus 3 into 2 plus 2. That is 2 square is 4 minus 3 2s are 6 plus 2. 4 plus 2 is 6. That is 6 minus 6 is 0. At the end we will get 0 remainder. So again x minus 2 is the factor of x square minus 3x plus 2. Here these are the two methods. The first method is the direct division, where we actually divide the x square minus 3x plus 2 by x minus 2, and at the end we will get the remainder 0. In the second method, we have to follow the two steps. The step 1 is put the polynomial x minus 2 is equal to 0, and we will get a point that x is equal to 2. In the next step, we have to replace by its value, that is 2. So in second step, replace x by 2, that is x square converts into 2 square minus 3 into 2 plus 2. Overall, after the calculation, we will get the answer 0. Again, that means remainder is 0. So we will say that x minus 2 is a factor of x square minus 3x plus 2. Next is to find out the roots. Before to find the roots, let's discuss what is a root. What is the root of a polynomial? Actually, the roots are the points which will satisfy the polynomial exactly. Exactly means when we substitute the point in the given polynomial, we will get the answer 0. So how to find the root? Simply put the entire polynomial equal to 0 and solve for the unknown variable. So what we have to do in this step, in this slide, we have to find the roots of a polynomial. For that, there is a simple step. We will put the entire polynomial equal to 0 and solve for the unknown variable. So the example is x plus 2. Polynomial is x plus 2. We have to find the root for this polynomial. We have to follow this step. Put the entire polynomial equal to 0 and solve for the unknown variable. And what is the unknown variable here? That is x. That means we have to solve this expression for the x. Now on solving, I will get x is equal to minus 2. So that means minus 2 is the root of this polynomial. Similarly, let's have one more example where px is equal to 3x minus 7, and we have to find the root for this polynomial. Again, put the entire polynomial equal to 0 and solve for the unknown variable again. 3x is equal to 7. Minus 7 turns right hand side as positive. Now 3x is equal to 7 replaces as x is equal to 7 by 3. So this is the value of unknown variable x. So that means x is equal to 7 by 3 is the root of this polynomial. So this is how we can find the root of a polynomial. In the last slide, we have discussed that how to find the root of a polynomial. Now let's do how to check if a point is already given, how to check that the point is root or not. So we discuss with the example, check x is equal to 2 and x is equal to 3 are roots of x square minus 3x plus 2 or not. So what steps we have to follow? Simply substitute the given point in the polynomial. If we will get the answer 0, that given point is the root of the polynomial, otherwise it is not. So we have to check x is equal to 2 is root of this polynomial, yes or no. Simply substitute x by 2. X square means 2 square minus 3x means 3 into 2 plus 2. On calculation, I will get 2 square 4, 3 2s are 6 plus 2. That is 6 minus 6, that is 0. At the end, I will get the value 0. So yes, x is equal to 2 is root of the polynomial. Now let's check for the x is equal to 3. Is this root of this polynomial or not? Again, follow the same steps. Replace x by 3. This is 3 square minus 3 into 3 plus 2. 3 square is 9. 3 3s are 9 plus 2. That is 11 minus 9. That is 2. At the end, we will get the value 2, that is non-zero value. So yes, x is equal to 3 is not the root of the given polynomial. Means we have discussed that how to check the root and how to find out the root. Next is Next is, if x is equal to 1 is the root of this polynomial, find the value of k. Means in this question it is already given that x is equal to 1 is root of given polynomial. Here we have to find the value of a unknown parameter. So simply, if this point is the root of this polynomial, it will satisfy our polynomial. So let's start. Replace x by 1 here. X square means 1 square minus kx k into 1 plus 1. Because this point is root of this polynomial, this will give the remainder 0. So answer is equal to 0. Solve for the k. 1 minus k into 1 k plus 1 equal to 0. 1 plus 1, that is 2, minus k equal to 0. Now that is 2 is equal to k. At the end I will get the value of k is 2. The next is important results. The first result is, if x is equal to a is a factor of some polynomial, then x is equal to a is the root of that polynomial. What does this mean? This means that if you are having a root, you will easily find the factor. Or vice versa, if you are having a factor x minus a, you will also have one root. If x minus a is the factor, x is equal to a is the root. And the opposite is, if x is equal to a is the root, x minus a is also the factor. I will show you one example, that if x is equal to 3 is root of some polynomial px, then x minus 3 is factor of px also. So this is very important result, that if we are having a one root, you can convert that root as a factor also. The next one is, here we have to factorize the 2-degree term. The first is 12x square minus 7x plus 1. We will factorize this polynomial with middle term splitting method. What is middle term splitting method? That means this one minus 7x is the middle term. We have to split this term into two parts. How we can split this in two parts? Let a and b are two terms. We have to select a and b in such a way that plus or minus of these two terms is equal to middle term, and their product is equal to the product of first and third term, that means 12. Now select two values whose sum is minus 7 and the product is 12. Clearly the values are minus 4 and minus 3. The values are minus 4 and minus 3 because their sum is minus 7 and their product is 12 as we required. So 12x square, and now minus 7x split into two parts, that is minus 4x and minus 3x, and the plus 1. So clearly here the middle term splits into two parts. Minus 7x splits into minus 4x and minus 3x. Now what is common from first two terms? Means what is common from 12x square and minus 4x? Clearly 4 and x. The remaining is 3x minus 1. Again, now what is common from the last two terms? That is minus 1 only. 3x minus 1. One important thing is that these two factors are always same. Means if these factors are not same, that means your solution has some problem in the upper steps. So next, what is common from the whole expression? That is 3x minus 1. We will left with 4x here and minus x minus 1 here. So this is the factorization of this polynomial. Means 12x square minus 7x plus 1 factorized into 3x minus 1 and 4x minus 1. The next is 2x square plus 7x plus 3. Again we have to factorize this 2-degree polynomial. So again we will use the middle term splitting method. We will select two values whose plus or minus is equal to 7, that is middle term, and the product is equal to the product of first and third term, that is 6. So which two values are there? Clearly 6 and 1. That is 6 ones are 6 and 6 plus 1 is 7. So middle term splits into two parts, that is 2x square plus 6x plus 1x plus 3. Now again, what is common from first two terms? That is 2 and x. We left with x plus 3. Again, what is common from last two terms? That is nothing is common. We will say that 1 is common. So 1 into x plus 3. Again, we are having the both the factors same now. That means my calculation is correct. So what is common from the whole expression? That is x plus 3. And we left with the 2x here and plus 1 here. 2x plus 1. So this is the factorization of 2x square plus 7x plus 3. So the next one is factorize x cube minus 2x square minus x plus 2, and then factorize 2y cube plus y square minus 2y minus 1. So starts with this one. We have to factorize this. So again, this question is already splitted in 4 terms. So let's try to do this in this way. That what is common from first two terms? That is x square. We will left with x minus 2. And what is common from last two terms? Minus 1. That is x. This is positive sign plus 2. Minus get common, so we left with the minus 2. Again, look at here. These two factors are again same. Means my calculation is correct. Now what is common from the whole expression? That is x minus 2. I will left with x square minus 1. Now x minus 2, I can write x square minus 1 square as x square minus 1 as 1 square. Next is x minus 2. This is a square minus b square. This is the identity of a square minus b square. That is equal to a minus b into a plus b. So similarly, this splits into x plus 1 into x minus 1. So this 3-degree polynomial has 3 factors. The first factor is x minus 2, second is x plus 1, and the third one is x minus 1. The next is, okay, so now we have to solve this question. Factorize 2y cube plus y square minus 2y minus 1. Again, I will try to solve this question as the previous. What is common from these two factors? That is y square. So this is 2 plus 1. 2y plus 1. 2y plus 1. Again, what is common from last two? That is minus 1 only. So it is again 2y plus 1. Both the factors are same. And what is common from the whole expression? That is 2y plus 1 into y square minus 1. Again, as in the last question, we can write y square minus 1 as 1 square. Again, here we will use the identity a square minus b square is equal to a plus b into a minus b. So this is equal to 2y plus 1 into y minus 1 into y plus 1. Again, a 3-degree polynomial splits into 3 factors. The next is this is the first identity, that is x plus a into x plus b is equal to x square plus a plus b into x plus ab. Now we will solve the question using this identity. First of all, expand x plus 4 into x plus 10. Now simply this form is just similar to left hand side, because first two variables of both the factors are same, and the second variable of second term of first factor is 4, and the last term for second term of the second factor is 10. Now we will compare this one with the left hand side. We will get a, on comparing we will get a is equal to 4 and b is equal to 10. Now simply substitute the given values to the right hand side, because left hand side is already given. So we will, after comparison and getting the values, we will substitute the values in the right hand side. Now substitute a is equal to 4 and b is equal to 10 in the right hand side. So x square is here plus a plus b. A and b are replaced by, a is replaced by 4 and b is replaced by 10. X is here plus a into b means 4 into 10. Now the calculation is x square plus 4 plus 10, that is 14. 14 into x, that is 14x, plus 4 into 10, that is 40. So this is the solution of x plus 4 into x plus 10. Clearly this form is called factorization form or factored form, and the right hand side, this is called expanded form. The next question is, evaluate 103 into 102 using this identity. Simply I can write 103 as 100 plus 3 and 102 as 100 plus 2. So what is the main condition for this identity? That first values of both the factors is same. Look at here, x and x, both the values of first factor are same. So again here, both the first values of both the factors are same, that is 100 and 100. That means this identity is applicable here. Now on comparison I will get x and 100 means 100 in place of x, 3 in place of a, and 2 in place of b. Now simply substitute these values in the right hand side. X square, that is 100 square, because value of x is 100 here. 100 square plus a plus b. What is a and b? 3 and 2 here. So 3 plus 2 multiply by x, and here x is 100, plus a into b means 3 into 2. On calculation I will get 100 square, that is 10,000, plus 3 plus 2, that is 5. 5 into 100, that is 500, plus 3 2s are 6. And the overall answer is 10,506. And the last question is x plus 14 into x minus 4. Clearly first values of both the factor is same, so this identity is applicable. On comparison I will get the value of a is 14 and b is minus 4. Now simply substitute these values in the right hand side. So after substitution I will get x square plus a plus b, that is 14 plus b. Here b is negative, so that's why I will use brackets here. 14 plus minus 4 into x plus a into b means 14 into minus 4. So calculation is x square plus minus minus. So 14 minus 4 is 10. 10 into x, and last is 14 into minus 4, that is minus 56. So x square plus 10x minus 56 is the expanded form of these factors. The next is second identity is x plus y whole square, that is equal to x square plus 2xy plus y square. Again first question is 3a plus 2b whole square. Again we have to compare the values. After comparison I will get x is equal to 3a and y is equal to 2b. On comparison I will get the values. Now I will substitute these value in the right hand side, because left hand side is already given to me. So substitute these values in the right hand side. That is x square, and what is x? 3a. So 3a square plus 2xy, that is 2, x is replaced by 3a here and y is replaced by 2b, plus y square. Y square means 2b square, and the calculation is 9a square plus 3 2s are 6, 6 2s are 12, ab, 12ab plus 4b square. The next question is factorize 9a square plus 12ab plus 4b square. This is the reverse part. In the above set quotient, we find the expanded form of a factorization form. But in this quotient, we have to factorize this quotient. Means expanded form is already given, we have to factorize this. So clearly 9a square is written as 3a whole square. That is okay. And last third term 4b square is written as 2b whole square. Now the middle one term is that is 12ab. For that we will write it as 2 into 3a into 2b to fulfill this condition 2xy. I will split the middle term 12ab in 3 parts to fulfill my requirement, that is 2 into x into y. So this is 2 into 3a into 2b. Please check that it is equal to 12ab. Yes, 2 3s are 6, 6 2s are 12. A into b 12ab. Yes, this separation is okay. Now on comparison, x is equal to 3. Now compare this expression with the right hand side this time. Compare this with the right hand side. X is replaced by 3a and y is replaced by 2b. Now we are having the values x 3a and y 2b. Now substitute these values in the left hand side this time. Now when I substitute these values here, I will get 3a plus 2b whole square. So this is factorization form of this expanded form. And the last question is evaluate 102 square. Means 102 is multiplied by 102. So simply I can write 102 as 100 plus 2 whole square. And now this is a form of this x plus y whole square. X plus y whole square. When I compare this with the left hand side, I will get x is equal to 100 and y is equal to 2. Now simply put the values in the right hand side. When I put the values, x square means 100 square plus 2xy means 2, x means 100 and y means 2 plus y square, that is 2 square. And the calculation is 100 square is 10,000 plus 2 2s are 4, 400s are 400 plus 2 square is 4. The overall answer is 10,404. The next is third identity, that is x minus y whole square. Similar to last identity x plus y whole square, this is x minus y whole square is equal to x square minus 2xy plus y square. Let's start with one example, that is expand to 3a minus 2b whole square. Again you have to do the comparison with the left hand side where is x minus y whole square. On comparison I will get x is equal to 3a and y is equal to 2b. Now I am having the values of x and y. Simply substitute these values in the right hand side. When I replace x by 3a and y by 2b, look at here, x square is equal to 3a square minus 2xy, that is minus 2 into 3a into 2b plus y square, that is 2b square. And the calculation is 9a square minus 12ab plus 4b square. This is the expanded form of these factors. And the next is factorize 9a square minus 12ab plus 4b square. Again the expanded form is given and we have to factorize it. So first of all, 9a square is written as 3a whole square and the 4b square is written as 2b whole square. Again we will split the middle term 12ab in such parts that this will fulfill our requirement, that is 2xy. Here this is 3a square minus 2 into 3a into 2b plus 2b square. On comparison, compare it with the right hand side, I will get x is equal to 3a and y is equal to 2b. Now substitute these values in the left hand side. I will get 3a minus 2b whole square. And the last question is evaluate 99 square, means 99 multiplied by 99. What is the answer? So simply I can write 99 as 100 minus 1. That is 99 square is 100 minus 1 square. Now this is of the form of left hand side, that is x minus y whole square. On comparison it with the left hand side, I will get x is equal to 100 and y is equal to 1. Now I am having the values of x and y. Now substitute these values in the right hand side. Here x square minus 2xy plus y square. So simply x square means 100 square minus 2xy means minus 2 into 100 into 1 plus y square means 1 square. And the calculation is 100 square is 10,000 minus 2 into 100 200 and 1 square is 1. Overall answer is 99,801. And the next one is next identity is x square minus y square is equal to x plus y and the x minus y. Very favorable identity of the students. So factorize 16a square minus 81b square. So simply first of all we have to write both the terms as a complete squares. So we know that 16 is the complete square of 4. So 16a square is the complete square of 4a. That is 4a square. And similarly 81b square is written as 9b whole square. Now compare it with the left hand side. I will get x is equal to 4a and y is equal to 9b. Now put these values in the right hand side. One time plus, one time minus. Both the values get added one time and both the values subtracted one time. So 4a plus 9b and 4a minus 9b. The next example is evaluate 98 into 102. Similarly, I can write 98 as 100 minus 2 and 102 as 100 plus 2. This is of the form a minus b and a plus b. So right hand side is given. On comparing it with the right hand side, I will get x is equal to 100 and y is equal to 2. Now substitute these values in the left hand side. So I will get 100 square, x square minus y square is 100 square minus 2 square. The overall calculation is 9,000 minus 4, that is 9,996. And the last is very important identity, that is x cube plus y cube plus z cube minus 3xyz equal to x plus y plus z multiplied by x square plus y square plus z square minus xy minus yz minus zx. This is very much important identity. First of all, first question based on this identity is if x plus y plus z equal to 0, show that x cube plus y cube plus z cube is equal to 3 times product of x, y, z. And this is very much easy. So simply what is given to us? This is given that x plus y plus z equal to 0. So you have to replace x plus y plus z equal to 0 here in the identity. So I can write it as x cube plus y cube plus z cube minus 3xyz equal to 0, because this is value of x plus y plus z is equal to 0, and into x square plus y square plus z square minus xy minus yz minus zx. Now you know that whenever something is multiplied by 0, it always answers 0. So the right hand side is 0. Now the last step is x cube plus y cube plus z cube is equal to this terms, this side will write positive as 3xyz. That is the complete solution, that whenever x plus y plus z equal to 0, the sum of cubes of the variables, that means x cube plus y cube plus z cube is equal to 3 times the product of the 3 variables. Now we will solve one question based on that. The question is evaluate this value. This is just similar to find x cube plus y cube plus z cube. Here x is minus 12. On comparison, I will get x is equal to minus 12, y is equal to 7 and z is equal to 5. Before to solve this question, just check their sum once. What is the sum of x plus y plus z? This is minus 12 plus 7 plus 5. This is minus 12 plus 12 and that is equal to 0. So sum of x plus y plus z equal to 0. Now this condition is fulfilled here, that sum of the 3 variables is 0. Now we know that if the sum is 0, the sum of their cubes is equal to what? That is simply 3 times the product of all 3 variables. So similarly, minus y 12 cube plus 7 cube plus 5 cube is equal to 3 times product of numbers, minus 12 into 7 into 5. So now calculate what is answer. This is minus 36 into 7 5s are 35, and the answer is minus 1260. So students, this is all about the chapter. Thanks for watching us. Please like, share and subscribe our channel to watch more videos. Thank you.